So in this video, what I want to show is how to change our template to deal with things like if we change our instrumental parameters to have longer temperature fractions, or if we change our temperature fractions, what we'll actually have to change on this template. So to begin, on the right side, as I talked about before, we have our transmittance calculations, our gray box with calculation no split point, and as well as our reflectance calculations. So all three of these areas we will not have to change. There's functions built into this program so that it's going to float based on what sample you insert with different instrumental parameters. But the one thing that we will have to change is our concentration, this graph here for each temperature fraction, and that's if you're changing if you change your temperature fractions, or if you change time in those temperature fractions, you're going to have to change the template to correlate with those changes. And then the last thing we'll also have to look into changing is these graphs that are preset for a specific instrumental parameters and specific lengths of time for sampling. So going forward, I'm going to copy and paste over a sample that has a longer runtime than this template is made for, and show you kind of what we have to do to adjust for this. So as you can see, this step it's a lignin ramp step with an ambient step, and the one I'm going to load it has a longer 890 degrees Celsius temperature fraction, and that's going to affect a couple of things within this template. So I'm going to go ahead and copy and paste over this new sample with a longer runtime, and we're going to see that if I scroll over, as I mentioned, these red, gray, and green boxes, it doesn't affect any of our calculations here because they're all built-in functions. But if I scroll down and we look at our graphs, we can see that we don't see any calibration peak at the end in this graph, or as a matter of fact in this one either. So all that means is we'll have to go in and into each graph and right click and select data, and then just change what these graphs are using for their series values. So we'll just have to go in here and then scroll down and highlight the total selection now, because this time frame for this graph has become longer. So I'm not going to show you that because that'll take quite some time, but I want to also show you, so not only do we have to change these graphs to accommodate the longer time frame, but we'd also have to go in and change these different temperature fraction times. And the reason we have to do that is, as I mentioned before, so we have a longer time frame in the 890 degrees Celsius fraction. So in this case, instead of a 320-second time frame in 890 degrees Celsius, we're actually increasing this by 360 seconds to a total of 720 seconds. So what that means is we'd have to go in where our area is calculated for this and go in and change our sum. So if I scroll down to the bottom of our worksheet, I can see what this time frame is actually summing, and we can see this blue box area, it's taking the total sum of that time frame. And if I scroll down to where it's stopping, we can see that we actually have more time here in the 890 degrees Celsius fraction. So I would have to go in here and scroll this down all the way till the end of that fraction. And a key thing to remember in this case is we have a transit time of 8 seconds, so we want to include that in our time frame. So in this case, we want to go 8 seconds past 890 degrees, which we count here. So I'll have to move it 2 more boxes down, and then everything should work out for that. So we pull that 2 more down, and then there we fix the problem of this temperature fraction. So that's just something to look for if you are using different instrumental parameters than the one that the template is built from. You'll just have to go in and change your graphs, as well as change if you are looking at different carbon concentrations with each temperature fraction. So just something to account for if you are dealing with different instrumental parameters.